Alright class, so this is the third video of today for January 12th, Friday, and we're just going to basically follow up on the last lessons and now start using the number line, which I've already shown you a couple times, but now we're going to start graphing inequalities on a number line in order to show their solution sets, which is a vocabulary word we learned in the last video. Just as a reminder, solution set is all of the solutions for an inequality. Because like we learned, an inequality can have more than just one solution. It's not like an equation where an equation only has one solution. An inequality can have multiple solutions. I definitely think that's worth noting. Let's put it over here. An inequality may have multiple solutions while equations only have one solution. And expressions have no solution. So an inequality may have multiple solutions, as we'll see today, while equations only have one solution. So if I told you 3x equals 9, then x has to equal 3. And in an expression, something like, well, 3x does not have an answer. It can only be simplified, but we can't solve for x because there's no equal sign. So in an inequality, what you're going to learn today as vocabulary-wise is that the solution set shows all solutions of an inequality on a number line, but however, that's going to be just a little different because we're going to be using the number line to graph this. So the graph of an inequality is what's going to show all the solutions of an inequality on a number line. The graph, I don't like this color. Let's see. No, I don't like that one either. How about blue? There we go. The graph of an inequality shows all the solutions of an inequality on a number line. An open circle is used when a number is not a solution. An open circle, and you'll see what this means in just a little bit. An open circle is used when a number is not a solution. A closed circle So a closed circle like this is used when a number is a solution. An arrow to the right or to the left shows that the graph continues in that direction. So we've got two different kinds of circles we're going to be using for this. We've got open circles. As you can see, this circle is not filled in. And then we have closed circles, and that circle is filled in. And so I've got an example here where I'm going to show you just what this means. We've already, again, talked about it a little bit, but I'm going to show you exactly what this means. So we're going to be graphing this inequality. The inequality here is y is greater than -8. So you already know that numbers that are going to be applicable to y are numbers that are to the right side of the number line, past -8. This number is our limiting number. This tells us that we're going to be doing something here at this -8. But now we're going to start using these circles to show whether this number -8, is part of the solution or is not part of the solution. So for this inequality, y is greater than -8. If I were to plug in -8, is -8 greater than -8? No, -8 is not greater than -8. -8 is equal to -8. So that means that -8 itself, this number itself, is not a solution to the inequality. So we're going to use an open circle, like it says up here. An open circle is used when a number is not a solution. So that's what we're going to do. We're going to put an open circle at -8, and then now we need to choose whether we're going to put our arrow to the right or to the left. We have to figure out which direction makes this true, if the arrow is to the right or to the left. Well, let's see. If I were to plug in, let's say 0, 0 is 0 greater than -8? Yes, 0 is greater than negative 8 because 0 is to the right of negative 8, and the number line goes from least to greatest. So 0 is a greater number than negative 8. So that means that my solutions are going to be traveling to the right. And we can double check that by testing any of these other numbers, negative 5, negative 6, negative 7. If I were to plug in negative 4, let's say, is negative 4 greater than negative 8? Yeah, it's to the right of the number line, so it is greater. So that means that the way that I'm going to graph this inequality, the y is greater than negative 8, is like this, having the open circle at negative 8, because negative 8 itself is not a solution. Remember, negative 8 is not greater than negative 8, it's equal to it. So we use an open circle, and then all the numbers to the right of negative 8 are solutions, so that's why our arrow goes that way. Now I want to show something using the greater than or equal sign. So this could be a little different if this was y is greater than or equal to negative 8. So in this scenario, if we were to plug in negative 8 like we tried up top, negative 8 is equal. Is it negative 8 greater than or equal to negative 8? Yes, it's equal to it. So that means that in this scenario, for the second inequality, negative 8 is a solution. And so we're not going to use an open circle like we did here. We are going to use a closed circle, so one filled in. And then the numbers that are greater than negative 8 are still to the right of it. So the only difference here is that because of this equal sign, we are using a closed circle to represent that negative 8 is part of the solution. Whereas up here, negative 8 was not part of the solution set. So that's how the equal sign on the greater than or less than is going to change whether you're using an open circle or you're using a closed circle. Because like we said, we're using a closed circle is used when a number is a solution. Okay, so now hopefully all of that made sense. If it did not, again, please ask questions. Please just raise your hand. You can tell me I don't get this. We'll see where you're at, and I'll do my best to explain it to you. Here I've got 4 on your own questions for you, and 6, 7, 8, 9 that I would like you to do on your own, and then have me check to make sure that you have correctly graphed these inequalities. Remember, all your answers should have either an open circle or a closed circle, and an arrow that moves either to the right or to the left. Just as a reminder, the number that you are going to be basically working at are the limiting numbers here, negative 1, 4, 1.4, and negative 1/2. So go ahead and try those on your own. Once you've completed the first 2, please have me check your answers so that I know you're on the right track. That way you're not wasting your time and having to go back several times.